Please pause the video for a moment and read example 19.5, dolphin therapy. Please read the description. I'm going to talk about a few key points, but will not be reading the whole thing to you. As I look at this, I think about there's some things that sometimes students will ask about. So for instance, mild to moderate depression, why wouldn't we worry about treating major depression with this if we find that if we're severe depression, if we find that animal care works? Well, you notice that they had them discontinue their treatment of drugs and psychotherapy for 4 weeks. If someone was very severely or severely clinically depressed or majorly depressed, it would be unconscionable to actually do that. It would go against all care guides. So you have to be careful how you design a study, and they have to be thinking about this. When human subjects are involved, there are lots of protocol that need to be followed. Also, just want to let you know at the end, after everything is said and done, everyone got to swim with the dolphins. So I thought that was kind of cool because I would have been sad if I'd found out everyone got to swim with dolphins and I didn't. Observational unit. I'm not going to write everything down here, but please make sure you're taking notes. Observation unit is each what? Well, they refer to them as each subject. So I would just go with each subject. Explanatory and response variable. So what response we're looking at studying is whether their depression score improved, whether they were better at the end, whether or not they improved. And what's going to vary from treatment group to treatment group is whether the dolphins were present, and that's categorical and binary, and whether or not improve would also be categorical binary. So they're wondering if there's substantial improvement. Is this an observational study or a randomized experiment? Well, hopefully you thought randomized experiment because subjects were randomly assigned to swim with dolphins or to not swim with dolphins. Why did the researchers include a comparison group in this study? Why didn't they just see how many patients show substantial improvement? What they want to do is what they're trying to see is how much is it better with dolphins than without dolphins? So everyone got the same sunshine, we're in the same location, it's an amazing study. But here we're really able to tailor down, and to hone down and see, okay, now we've got this group who's doing everything else the same except for swimming with dolphins. We need a comparison group, okay? Why did the researchers randomly assign subjects to treatment groups rather than allow them to choose themselves? You don't want there to be psychological bias to be part of it, regardless of whether you like dolphins or not, or what have you. We don't want those, we don't want the biases from the subjects to come in. Gee, the researchers did not tell subjects about the other group. Why is this important? Well, you may feel good or bad depending on what group you ended up in. Maybe you hate dolphins and you're just grateful you didn't end up in the dolphin swim group. Or maybe you love swimming with dolphins and you end up not with that group. So there are lots of things that could happen. So that is one way to blind. We don't tell the subjects what's going on with the other group. But the researchers also did not provide information who was in which group to the medical professionals who evaluated the patients. This is also important. So by not having them, the people who are doing the evaluating, know what group they were in, they avoid bias from those medical evaluators. This is called, by having the subjects not know and the evaluators not know, is called double blinding. In this case, the researchers are effectively a third party. So final note set of this class. 3 principles of well-designed experiments are comparison, randomization, and blindness, preferably double blindness. Comparison in the sense that we have a control group. So there's some sort of control group. Important notes. Taken as a whole, there are 2 crucial questions to ask of any statistical investigation. To what population or process can we generalize the results of this study? Okay, we want to know how far, who can we generalize this to? Can we reasonably draw cause and effect connection between the explanatory and response variables? Now, remember, we can only do cause and effect if it's an experiment, not if it's an observational study. Ideal studies make use of two kinds of randomness. Random sampling from the population allows for generalizing results from the sample to a large population, which is great. Random assignment to treatment groups permits cause and effect conclusions to be drawn. So we need that experiment which uses random assignment to allow for there to be cause and effect. Many studies make use of one of these or none of these. It's important to know how the study is set up before you draw in conclusions so you can see the scope of the conclusions depending on the study and who you can, what inferences to what population can be drawn. Now, the best is obviously random sampling from the general population and then randomly assigning them to one of the treatment groups. And you'll know this is what's inside these is what's just described. Random samples selected from one population, units are then randomly assigned to different treatment groups. Then we can draw cause and effect, and we can make inferences back to the population overall, which is pretty amazing. Now, if there is no random assignment, you'll notice you can only ever draw association. You cannot draw cause and effect. So random assignment is the key as being part of an experiment, so that you can draw cause and effect conclusions. Now, you may be like, well, why would I bother if I have no random assignment and no random sampling? We can still conclude association, and it will be limited to people like those in the sample, but that still may be quite a large group. Random assignment, and you may be like, well, why don't we always just do random sampling and always get the most powerful of all of them? Well, I actually had a friend I lost to pancreatic cancer, and he actually was in one of a special trial. And if there had been a random sample, who would you randomly sample from? All people? Well, not many people have pancreatic cancer. All cancer patients? Once again, not many patients have cancer patients have pancreatic cancer, and so on and so forth. Also, it would be the trials were targeting a specific type of tumor. So yes, they were randomly assigned either one treatment or another treatment, but it wasn't random sampling per se. But does that mean it's not useful? No, because inferences are limited to other observational units like those in the sample. And that's fantastic because that would, if they did find that one drug did work much better, they actually switched everyone partway through the trial to this one drug because the results were so amazing. And so would it be very helpful to be able to draw inferences to other ones like in the sample, other people who have this specific type of pancreatic cancer? And the answer is most definitely. So when we're dealing with comparing two or more groups on a response variable, we need to evaluate how unlikely the observed differences between the groups are to have happened by random chance alone. By random chance, excuse me, alone. If these observed results are unlikely to have happened by random chance alone, we have statistically significant results. Now this is going into Stat 252. Okay. So here we're introducing you. Yes, this is fair to ask questions, general questions like these, multiple choice kind of questions on random assignment, like what kind of conclusions can we draw, and what kind of inferences. So if there's not random sampling, we can only draw inferences. They're limited to other observational units like those in the sample. Thank you for a fantastic quarter and have a great rest of your day.